Hi everyone, this is yours truly, Lady Emmanuel. Here we go. This lesson is about modeling with quadratic function. And let me go ahead and write down my lovely name. Sometimes I put Lady Emmanuel, sometimes energetic Emmanuel, Queen Emmanuel. Just to go, today's date is March 6, 2015. When you're looking at this, it's no telling what day it will be. It was most definitely be after our lovely spring break. Way, yay. So here we go. I'm just going through what you're going to do when you come back to school on Monday after spring break, um, 2015, March, okay? Here, guys, you got to learn how to just read through things. I know you're thinking, well, this is math. Why do I have to do this? Keep in mind, the state of Texas will get ready for STAR assessment. Any content you got to read. It is just a part of what it is. It's part of reading. So here we go. The learning target is model a real world situation with a quadratic function. You may be saying, Miss E, what is a quadratic function? I'm glad you asked. It in standard form is ax squared plus bx plus c equals f of x. You could write the f of x before that, which is the same as y. So we could write it as f of x equals ax squared plus bx plus c. Keep it in mind, a, b, and c are real numbers. Okay, or at least a and b, they're real numbers. Notice that the highest degree is 2. Therefore, it's quadratic because it's squared. So it's a quadratic function. The parent function for quadratic function is f of x equals x squared or y equals x squared. Okay, that's the same equation. That's the parent function, and this is the quadratic function in standard form. I didn't write it in vertex form yet. So we're going to model real-world situation with the quadratic function. Either one of these forms will work. You're going to identify a quadratic function. You would look at the equation. You would say, okay, the highest exponent is 2. The degree of the x is 2. So yay, that is most definitely quadratic. Or you look at the table, the graph, to determine if it's quadratic or not. If it's quadratic and you look at the graph, it will make a parabola, which is aka U-shape, whether it's open upward or downward. You would write a quadratic function in standard form. This is standard form. Look, I didn't read that at first. I just started thinking about everything, writing what I know. That's quadratic function in standard form. A standard form for you. And I just why I said that. Guys, when you're reading this, it's telling you strategies that would help you to learn this information in depth so you can create representations. The interactive word wall that I have, let me see, can I, I'm turning it to my word wall. There go the word wall right there, guys. I have it up there for you. You just got to make sure, I'm trying to make sure it's not blurry. There we go. They go to word wall in the class, so you can use that information to help you. I have to change it for quadratic function because right now it's for polynomials. I will update that before we come back, but we just got through with polynomial. Well, we're really not through with it. We're going to continue on with it because quadratic function is a polynomial as well. So back to the paper. Okay. I just wanted you guys to see that the word wall, that's a suggestion. So use the word wall. You mark in the text. This right here, guys, annotate. Okay? Annotate. When you annotate, it helps you to understand information. Look for a pattern. Look for 1, 4, 9, 16. So if you look for 1, 4, 9, 16, you would notice 1, 4, 9, 16. You'd be like, oh, that's 1 square. Oh, that's 2 square. Wow, the base is increasing about 1 unit. However, the exponent is staying the same. Look for those patterns. You want that. That helps you. That's a part of math. Looking for the patterns. Discussion in groups. You guys, you know the classroom is set up in group. You know we got all apart. It may not be facing each other, but it's set up. So use each other when it's time to discuss. to help you to understand. So this is basically what I'm showing you now. It's like an intro to what we're about to do for is in quadratic. I put on here lesson 29.1. However, let me throw this in here. When you throw, Lord Jesus help us. But anyway, we're going to do modeling with quadratic function. We're going to graph. We're going to be graphing and analyzing quadratic function after spring break. This is our next unit. Then we're also going to do translation of quadratic parent function. That'll be the next lesson coming up. And what is the next one? Transformation. It's transformation with vertical stretch and compression of quadratic function. We will be doing multiple transformation. That means shifting vertical or horizontal or compression and stretching. More than one thing. Another part of this unit is solving quadratic equation by graphing and factoring. So we'll be solving by graphing. We'll graph the function. Also factoring. I'm going to do a little section for factoring when we get there in details. We will be identifying the axis of symmetry and vertex in this unit. Also, we will be solving equation using the quadratic, I'm about to say the quadratic formula, but this right here is the square root method. We'll do the square root method. We'll be doing completing the square. Completing the square will be another lesson. And the quadratic formula. Those are some methods we'll be using, and you'll be able to choose the method using the discriminant to determine which method would best fit to way to solve it. And also we'll apply quadratic equation, meaning that we would do real world situation. So that would be the quadratic unit that we'll cover after spring break, guys. So now I'm going to make a series of videos, so get ready for it. And that's yours truly, Lady Emmanuel. Quadratic function unit is coming up. Thank you, guys.